Hey Taylor, it's Andreas. I can see you, I can hear you.
Hey there, good to hear you.
A- All good.
Welcome back. Hey there, Carson.
Good morning, afternoon, and evening, everyone.
Mhm. Cover all the bases. Hey, David.
Hey guys.
We'll give it another minute or two, let folks trickle in.
Taylor, I'm going to give you remote control access as well, so you can
Oh,
just advance through, and I'll do that for everyone else as well.
oh.
Taylor, can you just give it a quick try? All right, sweet. I see you moving your mouse. When I see if pressing the space bar, the arrow keys does anything. Okay, awesome.
All right, I think it's about three after. Go ahead and get started. Folks may continue to trickle in. John and Seth, you guys are co-hosts, so if you see any admittances, just let folks on in. Awesome. So we're here to talk about some stuff that we've been jamming on for a while, the location protocol. So for any folks that don't know me, I'm Taylor O'Shan, an associate professor in the Department of Geographical Sciences at the University of Maryland. And I've also been leading the Easier Data Initiative, which is a project in collaboration with the Filecoin Foundation for the Decentralized Web, where we've been looking at ways to bring geospatial data into the decentralized web. And then we've more recently been teaming up with Astral um, under the umbrella of the Decentralized Geospatial Collaborative on this latest project. So previously, we've been working with the Stack protocol to make data kind of more discoverable on IPFS and Filecoin. And so in this new project, we're taking a bit of a more, I think, expansive scope and trying to rethink really how we can make geospatial data more interoperable in general on the decentralized web. And so we're going to tell you all about that now. Oh, we've got a bunch of people in the waiting room. All right. If you guys can keep an eye on that as well. So you'll hear from a bunch of us today. We'll try and cover a bunch of different aspects of the location protocol. I don't think it's advancing the slide set, so I'm just going to say next slide. Awesome. So cover a bit of the motivation, and then we'll go into the core technical specification, keeping it at a high level. And then we want to cover some of the applications and integrations that we've put together as a little bit of a demo, just to show you all how this can work. And then we'll talk about some developer tools and kind of an ecosystem vision and some more specific applications that we're thinking this could be useful for right off the bat. I think in terms of style, feel free to kind of like pause, ask questions. John just mentioned throw some questions in the chat. We're happy to kind of keep this as a discussion because there's really so much that we could talk about. We've kept this kind of simple. We'll go through this. I think it'll take about 25 minutes, leaving lots of time for discussion. But yeah, please just chime in if there's stuff that we're not covering at the moment that pops to your head. And next slide. So the highest level of motivation we can really provide is that the location protocol really sits at the middle of the geospatial web and the decentralized web. And our goal is to kind of bring these two things together. Those are both really expansive things. We could, spend lots of time unpacking what is the geospatial web and decentralized web. We'll talk a little bit about each of them, but that's kind of our goal with this, is how we can tie those two entities together. So we want to take the best of both worlds and bring that into one protocol. Next slide, please. So to kind of contextualize everything, the current situation that we're in right now is location-based services are already a huge component of the web. So things that are built around location, we have things like routing, check-ins, spatial search on maps, geofencing, social media check-ins, tracking devices. Those are all creating geospatial data and using geospatial data kind of from first principles. But then you've got lots of applications that are not necessarily geospatial applications, but use geospatial data, whether it's an app that helps track, impact or helps people, capture different types of tree species, right? So that they're not actually thinking about geospatial data up front, but they're still using geospatial data. So there are lots of things that are at the core of the web that are interacting with geospatial data. And that currently we really rely on centralized entities to provide convenience and trust. So it's pretty easy to spoof locations. Most apps, you could put in whatever you want. And there's not really a way to persistently track that trust. So we usually kind of just take the trust of the authority creating the data and say, okay, we trust them, they've created the data. And then that data goes out into the world and it gets used in different ways, right? So we might trust Twitter to create a geolocated tweet, but once somebody scrapes that and uses it for something, that convenience is kind of lost. So we don't really have long-term verifiability. And it was never really designed to interoperate with things like peer-to-peer networks or distributed ledgers. And so on the flip side, we've got these decentralized systems, and they don't typically have a structured and standardized method for working with geospatial data. So folks may be doing that. They may not be as familiar with some of the existing standards, or they may just not be thinking that their data could be important to somebody else down the line in a different kind of context. And so thinking a little bit about how we can connect these things could go a long way in terms of interoperability in the long term. Next slide. This kind of brings us to unrealized opportunities, we think, at least. So we know that well-designed Web3 systems can bring a lot to the table, enhancing user rights, giving us more control over our own data, things like immutability, attribution, tamper evidence. And we know that things like smart contracts will require verifiable spatial information. So there's an unmet need there as well. And there's a growing need for compliance reporting, things like measurement reporting and verification. Things like localized agent behavior are on the rise. So we'll see agents consuming and also creating geospatial data. And so really, we're going to need more trust at the center of all of these things. And so that brings us to the need to develop kind of a spectrum of certainty, right? How do we know that this geospatial data is trustworthy? And that trust could really be a spectrum of certainty that we build about the evidence that comes with that geospatial data, right? So we might not need a high level of certainty for every application. So we can think of it as a kind of a tiered system. And some of the highest level applications might need some really strong or multiple sources of evidence for us to trust that. So we won't talk too much about these proof of location strategies, but they're important to the kind of protocol that's been put together because it's going to be able to accommodate that as we grow the need for these types of things. Next slide. So that brings us to the location protocol. What is it? It's a common format for signed records that have spatial information, right? So we're bringing these two things together, digital signatures and well-formatted spatial information. And it can be lots of different types of spatial information. I think today we'll talk a bit mostly about the basic kinds, points, lines, polygons, maybe imagery, but it can be a place as well. It can be more abstract, it can be raster data and beyond. And the system that we're working with, it's can think of it as self-contained units of spatial data. So things like a row in a database. However, it's portable, and it adds this layer of cryptographic verification in the form of not only digital signatures, but we'll talk about some others as well. And that's all right. I was just going to say the last little bit there is this interoperability, not only between applications, but between both decentralized and more conventional centralized systems. So the things that we're focusing on are consistency, interoperability, and verifiability, I think are the three core. Next slide. So the core design principles are that we wanted to ground it in established standards. So we're not trying to create new standards where we don't need to. We want this to work with those standards that everybody already knows and loves. We wanted to provide minimal extensible foundation for working with spatial data. So it should work really simply with the things that are out there already, and then we can build up from there. And it's implementation agnostic. So today we're gonna present kind of our reference implementation, and Seth's going to talk a little bit about that. But we kind of ask everyone to keep in the back of your mind that this could be built in many different ways, and it's very generalizable. And then finally, it supports both public sharing and selective disclosure of location information. So although the things that we present are going to be about being able to disseminate data and preserve data, there are also ways that one could decide not to share all of their information as well. So it's not simply about sharing everything all the time, but making that flexible for the user. So I'm going to pass it over to Seth now, who's going to talk a little bit more about the protocol in detail.
Hey, everyone. So I'm going to talk about some of the framework components of the location protocol, and the fundamental core structure of the location protocol is the location protocol payload, and that just represents a geospatial artifact. The next component is the verification layer, and that represents the implementation scheme for digital verification of information. So this could be an individual or an entity signing off on an action, say a journalist capturing information from a protest, and that action of capturing creates an authentic digital signature that's verifiable. Another example of a verification layer is a system that's able to verify location information, validate a set of conditions, or generate tamper-proof digital location signatures on a user's behalf. So, for example, restricted access to like a VIP only area of a concert. And then, but ultimately, the takeaway is these are just ways of like the big takeaway is these are ways to validate authenticity of information. The LP payload not only contains information about not only does it contain location information, it's extensible by design and can contain additional contextual information or attributes. Say, for example, back when I just an example of the VIP area only of the concert, it could be for a specific area. It could have attributes of a specific area, specific time, the user, so on and so forth. And last but not least, standards compliance. We align with many established geospatial standards, ensuring that we can effectively translate that raw location information into the desired formats. So what is location information? Definition, from what I was looking up, is it's essentially data containing information that directly or indirectly identifies a place or an area. So let's say, for example, I'm hiking and I wanted to go hike the Presidential Range up in New Hampshire. One of the things I want to identify and understand is like, what is the area that I can hike in? So we got these green areas that represent the forest areas. The next thing I would want to really understand about my travels and specifically location based is like, hey, what is a trail that I'm going to be hiking on? Well, I'm probably going to be hiking a section of the Appalachian Trail, so I just want to get an idea contextually of, hey, where is the trail? Like, how does it go through the Presidential Range? And then I'm gonna be doing this for a couple of days, so I also need to understand like where the shelter the shelter, so I can stay overnight. So here's an example of where those particular shelter locations are. And then last but not least, I need to find out where I can park. So I can go there, park, and just head out for the day and start hiking. But what does this all have in common? It's the these are digitized location data. So we got area that represents the boundary of the forest. We got the lines that represent the trail. We got points that represent the shelters. All that is translated into interoperable formats that can be used across the ecosystem. So that kind of brings us to the basis of what the LP payload is, and that's based off of the location information. So at a minimum, an LP payload, a location protocol payload, conforms to these base fields. So and it contains a SRS, which represents a reference system that defines how spatial data is represented. And then we have a location type, which is how that location information is encoded, or simply how it's structured or formatted. So over here to the right, you'll see a picture of one of the shelters from the previous map. That encoded information and GeoJSON structure is what it looks like over there in the LP payload variable. And then another component, another location is like the actual data that we actually pass into this payload. So again, that would be the coordinates that represents the actual data. And then the spec version, which is the version of the specification used to generate the attestation. As I noted before, the LP payload can be extended with additional more common attributes like media data and media type to store content for on IPFS or Filecoin, a note or a message, or any kind of other arbitrary field that best suits the need for the application or use case. And the proof fields over here, they represent strategies for digital verification of location within the LP payload. So we can have one or more recipe types or strategies that can be used for verifying or validating the location of something to a degree of a certainty. So that's where we're generating trustworthy spatial information. And as I mentioned, we support a suite we support various different location types that support the parsing and validating of geospatial data. So we support coordinate decimal, which is something typically that you would get from a GPS reading. GeoJSON, as we pointed out earlier, it's a object representing a geographic feature as points, lines, or polygons. Place names, addresses. These are all very specific location types, but inherently are encoded from some location. But the idea, what I want to like emphasize is the fact that the flexibility to expand on supporting more data formats. So right here, as noted, represents a subset of some of the supported location data formats, but we're welcome and open and would love to learn about what other kind of location formats that you don't see here that would be useful for your particular applications and use cases. So the location protocol, it is, as we noted, is implemented built on the Ethereum attestation service. But the location protocol itself is an open specification, and by design is implementation agnostic. So this reference implementation of the location protocol is built on EAS for the creating, signing, and verifying and distributing location attestations on chain or off chain, whereas the core of the location protocol, the LP payload, is where the location information lies. So to kind of give you some context of what that looks like visually, so this is the LP payload within the EAS framework. So within green is the actual data payload, and it contains the base fields that represents the location information. Can be extended with some of those common fields, validated with proof fields, and that and within EAS framework is attached to the data field, and is wrapped up within an attestation object. And that attestation object itself is what's digitally signed for the attestation. So that's just a high level overview of like what the implementation of the location protocol, how that fits within the EAS framework. I'm going to pass it over to some of my colleagues next to just showcase some of the demonstrations on how we're using the location protocol within EAS. So I think I'm going to be passing over
Next slide.
to you.
Yeah, I'll be covering. Yeah, cool. So the first demo we prepared was this notion of a QR code check-in. So this idea that event attendance is a pretty kind of prevalent or ubiquitous activity that most of us have done multiple times and in different capacities. So QR codes themselves are really an easy way that we can kind of bridge the physical interactions or physical world with digital information or the digital world. We might use them, say, at a conference or for geocaching or some kind of location-based gaming. And so the location information, as well as verifiable identifiers, such as a secret, can be embedded into the QR code. And we can take that and then map that into the location protocol and create a compliant attestation about where somebody was at a certain time. Next slide. So the workflow of this demonstration application is that you've got a unique QR code created that contains geospatial metadata as well as a secret. And then you've got hash combination of embedded secret with user's wallet address for verification. And then we can create an attestation. So the QR metadata is mapped to the payload with the coordinates and the proof fields. And then the verification process is that event organizers can verify whether that secret is correct as evidence of physical presence. Next slide. This is just an example of what the payload looks like. So this is quite similar to what Seth had showed just a minute ago, but you can see that you've got the location type as GeoJSON here, and then you have a JSON object that's telling us that this is a point geometry as well as the latitude and longitude for the coordinates. And we've got our coordinate reference system, our spec version. And in this case, we've just added two extensible fields. We've got the memo field and the event timestamp field that we've used to expand this particular attestation. Next slide. So we've got a little video demo walking through what that looks like. I'm not actually hearing it, Seth.
I guess I have to be unmuted.
From the DGC. This video here will walk through a high-level example of what the location protocol might look like in practice through the use of QR codes. So where might this apply? Well, there might be cases where you might need to scan a QR code with your phone to prove or check in to a particular location. For example, a restaurant. If you're checking into your reservation, there might be a QR code posted up with some paper that you can use to essentially sign in and say, yes, I'm here, I'm going to wait for my table. Or an alternative example would be a scavenger hunt that exists on a college campus. So what I have here is I have a program that is listening to an EAS schema, which is currently posted to the Sepolia network. And you can see the last attestation was generated about a month ago. And I have an example QR code here that's pointed to a application that is running in the background with some metadata encoded to the URL, for example, a little secret and some coordinates. So what I'll do is I'll go ahead and I'll begin screen recording on my phone, and I will bring up the camera. I will navigate to this link, and you can see here that the page throws an error. MetaMask is not installed, but let's just say MetaMask was my default browser on my phone. It would by default pull up MetaMask, go to the browser, and we need to go to this web page here, picked up by the QR code, and it would automatically prompt me for a wallet connection and ultimately a small network fee to generate that attestation. So I'll go ahead and hit confirm, and you can see it's processing. And this might take a few moments, about half a minute maybe. And you can see the attestation was successful. And on the left-hand side here of my desktop, we have some metadata that was logged to the terminal. Now, if I go ahead and pull up the schema link on EAS scan, I can go ahead and refresh, and you can see we have a new attestation. So the point of this validator on the left-hand side is it is an example of how things might be tracked or validated or verified by a third-party service. In this case here, this is just a small TypeScript program that runs in the background, but ultimately this could become a smart contract or something else that is hosted elsewhere. Thank you for watching. From the DGC.
Perfect. Next slide goes into the next demo app. Pass it over to Adrian.
Yes, hi everyone. So I'll be presenting our work on integrating the location protocol with proof mode. And so by integrating with proof mode, we are looking to provide interoperability to an already trusted source of geospatial data. And so what is proof mode? So proof mode was created by the Guardian project in collaboration with Witness and OkThanks, and is a mobile app for capturing verifiable photos and media. It captures photos and videos with cryptographic verification and metadata. It records GPS, device fingerprints, network data, and environmental context automatically. And it creates signed zip files containing media and verification proofs for authenticity. Next slide, please. And so the opportunity that we see with proof mode is that, considering that proof mode excels at creating trusted geolocated evidence, we want to expand its impact through standardized formats. First, we know that proof mode successfully combines authenticated media with precise location data in comprehensive evidence packages. And we know that the location data currently exists in proof mode specialized format. And so we want to essentially make this data accessible to broader systems. That way, combining proof mode's trusted evidence creation with standardized location protocols, we believe that it can unlock cross-system operability. And so by integrating proof mode with our location protocol, we would like to make geospatial information consumable. So first, we think that it will, by integrating with proof mode, we're looking to keep the authentication and user evidence intact. And we are looking to convert the location data to standard format that other systems can consume. And finally, we're looking to store these location attestations on the blockchain to create permanent and cross-system interoperability. And so here we're going to talk about the payload more in detail. And as you can see, in addition to the essential fields that we use as part of the location protocol schema, such as SIS, location type, location, spec version, event timestamp, and memo, we are also using the recipe type and recipe payload fields to attest with proof mode. The recipe type is set as proof mode to indicate that it's a recipe of type proof mode, and recipe payload is an array with the first element being the recipe type, proof mode, and the second element being the IPFS CID of the zip file. In this way, anyone can verify the location attestation using standard location protocol methods, access the complete proof mode evidence package by retrieving the zip file from IPFS using the CID, independently validate all cryptographic proofs, divide fingerprints, and sensor data, and finally, maintain full evidence chain from the blockchain attestation back to the original proof mode verification data. And so we were able to implement this integration using proof mode's open source iOS code, and here's a demo video using the iPhone 16. So first, the user takes a picture using the proof mode app, and here we have to perform a small operation in order to create the zip file, since this is the content that we will be consuming as part of the attestation. So once the zip file is created, you can see that we've added a new button called Create Location Attestation, EAS. So the user will click on that, and then what will happen right now in the backend is that the system will parse the JSON file and will look that there is indeed location information. We'll extract this location information to add in the schema, and also we'll compute the IPFS CID and put that also on the schema. So here the attestation was created successfully, and we're going to look at it on the on EAS. So as you can see, the attestation was created and our fields were successfully created as well. And the users can here see the CID of the zip file.
Awesome. Thank you, Adrian. So just one more quick slide for me, and then I'll pass it over to John. So just to kind of demonstrate or talk a little bit about what we're currently working on and look to work on in the near future, we are looking to do some native integration with IPFS and Filecoin for storing the associated media for some of these attestations. So you might have a photo or a video that goes with somebody's attestation. It might not be a formal proof of their location, but it's still supporting evidence. And we can't really put too many large bits of information in the attestation itself. So we could reference it and store those elsewhere. So we're looking into that. We're very interested in how we can refine the specification. So which fields to include or keep in the core and how to name them. So if anybody has suggestions, thoughts, feelings, or applications, we would love some feedback and to work with you all. So and then developing applications along with community members, using different types of location data and location proof strategies to help develop kind of a series of recipes that others might find useful as well. And then finally, an ecosystem of developer tools, which John is going to tell you a little bit more about. Next slide.
All right, I found my microphone. Hey, cool. Thanks, guys. This is a really great overview. Yeah, so I'm gonna kind of give a brief recap to hopefully make sure it all sticks. And now will be a great time to pop any more questions in the chat so I can kind of try to address them as I talk through this. And then I'll also talk a little bit about some of the tools that we've been building that makes it easy to work with the location protocol with all of its kind of different features. So first and foremost, I'm gonna share, oh, actually, no, we've got the screen sharing already. I just kind of got off it, I think. I don't know where that went. Maybe I'll just take over and we'll call it that. So yeah, I'll talk a little bit about some of the tools, like I say, but just to make sure kind of we reiterate here, location protocol is really about structured spatial data, creating a common structure. And the reason for this is in decentralized systems, sharing data, when a node or a computer receives a message from another one, it needs to know how to interpret that data and how to parse it and process it. And so we wanted to bring that same structure to location data that you find in all sorts of other protocols like HTTPS and Bitcoin protocol and all of this. And on top of that, because we use digital signatures created with a private key, you can make sure that the data hasn't been changed. You can make sure of who created it. And with this location proof plugins library we've been building, you can also attach evidence that the kind of meaning of the location attestation is actually true in some cases. Not every location attestation has a proof attached, but sometimes they will. So here's a little bit of a corollary. If you imagine this to be rows in a PostGIS database, this actually adheres to the core features of the location protocol, right? We've got the spec version here, so we know how to interpret the data. We have the creator and the digital signature. Obviously, those are shortened versions of those, but for example, we have the location type, which tells which format the location data is formed in. We have the spatial reference system that shows where it's kind of situated. And then we have the location data itself in the format that's described by this location type. So this little PostGIS table or stylized PostGIS table is conformant with the location protocol. I'm gonna, I guess, jump ahead here to talk a little bit about some of the tooling we've been building, because a common data standard's fine, but this really gets useful when we can actually start to build with it, create applications, create experiences for people and for machines. So the first thing we've recently launched the beta version of the Astral SDK, which is a TypeScript library that makes creating location attestations easy. So under the hood, this uses the EAS SDK, which if you're not familiar with EAS, I recommend you go look at it. It would be really kind of helpful to understand what we're doing and a bit of why we're doing it, which EAS itself uses a library called Ethers.js, which is a really powerful library for interacting with the Ethereum blockchain. But I should be clear, location attestations don't need to be stored on blockchains. They can be signed and held off-chain. They can be held privately. They can be shared peer-to-peer. You can store or verify them on a centralized server in a normal cloud server like AWS, or you can kind of put them in decentralized systems like Ethereum, IPFS, Bitcoin. I saw Nathan talking about any blockchain you could technically store a location attestation. And again, if you think about this as kind of the location protocol base fields are the sort of required fields you need in a geospatial database, you can add any additional fields to that as relevant to your use case. So here we've got things like a memo. Maybe someone wants to write a little note on it. Maybe here, in this use case, we were talking to solar energy providers. Maybe they want to attach a meter data record to each location attestation that they create. That's completely use case dependent, and we don't make any assumptions about what's going to be appropriate there. We've also got a API running, which is essentially a indexing these records from the different places that they're stored and making them all easy to consume in an application via an OGC API features conformant endpoint, which serves GeoJSON. So even if you've got all of these different data formats stored on all these different blockchains, you can pull them easily into an application, and the API does some of the heavy lifting of doing those format conversions. But again, because you've got the location type in each record, those conversions are quite easy. So in another sense, this is an interoperability protocol for location data so that an application can take data produced for some other use case and make sure that it kind of can play well in the application code that the developer wrote there. And then one other thing we were kind of working on, it's a little more in design than in development, but it's a product we're calling Astral Scan, which is essentially a user interface for exploring location attestations and this is, you can imagine these are stored on blockchain. You can see a list of them. You can see them overlaid on the map. And maybe you can also even have an attestation creator or editor where you can create these records. So it's almost like a web-based application for interacting with this decentralized geospatial database and updating and fetching and verifying these records. So, at the end of the day, what we're trying to do is introduce a new way of working with location data that is useful for applications that are building on the decentralized web, but also really applications in any sort of decentralized or distributed system where there's not just one application developer building the entire system. Anytime AI agents or computers on a network or anything like that needs to exchange location data, and it would be helpful to have more confidence that that data was not changed in transit and that it was actually created by the kind of claimed originator, the author. That's where this structured signed data might be useful. So yeah, I'd love to hear any more questions. I don't know, Taylor, did I miss anything there? I kind of went off the slides.
That's fine. No, I think that's covered it up. Want to leave some time for some Q&A. So if we want to stag over to that now, we can certainly do that.
Okay, yeah, we've got a couple questions here. So, Justice, why not use DA so that anyone can write custom code on chain so that it can work on any chain instead of you needing to be on a new chain? By DA, do you mean data availability? I think that's right. So I'm here with a collaborator of ours, Adam, who we've kind of just been starting to look into this now. The reality is that these kind of records can be stored anywhere you want. So we've deployed kind of Astral supported EAS schemas on 4 different blockchains so that out of the box with our SDK, you can write location attestations to these different blockchains, but it can be kind of created and stored anywhere. And as long as it conforms with that data model, it's going to be able to be parsed and consumed by any other kind of location protocol compliant app. But it's a good question. And I think, Justice, I'd love if you'd share a bit more about your use case, maybe privately, and we can do a little bit of scoping and see if it would work as is, or if we want to build or integrate some new features into it. David, would all the attestations live on chain? If so, could they be queried as well? In the case of the logbook, will it be living somewhere? Yes, great question. So the first question, would all of the location attestations live on chain? No. No, I think probably most of these will never go near a blockchain. A lot of times this will be personal data that shouldn't be stored on a publicly accessible place. So instead, I kind of imagine I create a little location record locally on my machine. I sign it so that everybody knows where it came from if I ever share it with them, and they know that the data hasn't been changed. And then, as I say, that could be registered on a blockchain, but it also could be stored on a centralized server, could be sent to someone just peer-to-peer, so only they and I get access to it, and so on. There are benefits sometimes to storing them on blockchains and drawbacks, and so that's going to depend more on the specific use case. As for querying it, this is the reason why we've been working on this API. The API is an indexer that is polling the different blockchains and fetching new location attestations and storing them at this point in a centralized server that has a PostGIS database so that you can query, including query by location, right? You can send a query saying, send me all of the records inside of this polygon. The OGC API features endpoints support that. Other blockchain indexers do not support geospatial query parameters. So that's the reason why we've had to build our own custom indexer. But I think I'd love to hear, David, as well. I've been meaning to catch up with you for a while. I'd love to hear more about what your needs are and if we can provide infrastructure that would be actually most useful to you, or what kind of performance requirements you guys have. And the logbook itself, yeah, I mean, the logbook is really just a front end for visualizing this data. So at the moment, the plan is for the logbook and the indexer both to be centralized services. The indexer API is open source, so you could run it yourself and kind of fetch all of the attestations and resync your own collection of the records, but we think especially early on, serving this through centralized endpoints can be good enough to at least get some applications up and running and demonstrate the value of this. So, but yeah, Dave, I really, again, would love feedback and critiques. I know you've been building with geospatial data and decentralized systems for a very, very long time. Cool. Nathan, does off-chain also mean offline? Can it be used when a smartphone with proof mode doesn't have internet connectivity, or would you need to queue up a network transaction? Great question. No, it does not need an internet connection. So the answer is yes, offline is possible. The digital signatures are created on the local device with private keys that are held on the local device. So even if it's a device completely disconnected from the internet, you can create a complete location attestation and possibly, in your case, Nathan, including a location proof, which a proof mode zip file is a form of a location proof because you've done the metadata analysis. So yeah, no, we've got some use cases for biodiversity impact monitoring applications where they've got people out in the forest taking recordings and they're not going to be at internet for a couple of days. We're making sure that we can support those use cases and that you can create these signed location records, hold them on the local device until you get back to a network connection, then you can upload them to wherever you're going to upload them. Working on encrypted proof mode zip bundles stored on PFS. Yeah, that sounds really cool. That sounds really cool. We've also been talking a little bit about zero knowledge location proofs. And I haven't gotten too deep into it with Adam as our ZK genius, but thinking a little bit about how we might be able to create a zero knowledge proof that someone can verify that someone had credible evidence that they were at a particular location without necessarily sharing the evidence or even the specific precise location. Cool. Okay, that looks like the questions in the chat. Taylor, what's up?
No, I was just going to kick it to people if anybody wants to unmute and ask questions or have any other discussion points. Open it up.
Yeah, Gmo, hey.
Hey guys. Yeah, this is awesome. I'll be connecting with Seth later this week to kind of expand on some of the questions. But curious, I just want to clarify. So like actual proof of location, like anti-spoofing, is that something you alluded to, or is that built into this? I guess I couldn't quite confirm that.
Yeah, great question. So this is a first-class feature of the location protocol, but we haven't featured it here because we're still ironing out some of the details of the location proof plugins library that we're building. And we're going to have a session on that soon. I don't know exactly when, Taylor, we haven't really talked about it, but we're refining our exact approach of essentially how do we build a toolkit, a bunch of different tools for developers to be able to create or users to create little pieces of evidence that a location claim is true and then attach them to a location attestation.
Yeah.
So when I receive it on the verifying end, I can verify the digital signatures and look at the location data, but I can also review the evidence and make a judgment for myself as to whether or not I think they're actually there, for example.
And it's partially
Go ahead.
It's partially application specific, right? So different applications require different kind of thresholds of evidence. So it's not that I think that the protocol builds in necessarily spoof proof at the base level, but it gives you kind of that infrastructure to add in those layers of evidence. And so you can think about certain things might be easily spoofable, but when you start to stack them up on top of each other, it becomes pretty tricky. So it's just kind of like building these layers up of protection, and that might satisfy a different application depending on that.
Yeah, like triangulating the evidence.
Exactly.
Awesome.
Yeah.
Just a quick thought there is like with low Earth orbit constellations like Starlink having very low, very light, packets even at the cellular level, and they're thinking about wanting to reinvent GPS. It just sounds like the next way, a frontier of interest for Astral. I would imagine you guys should like reach out to them or equivalents. But another quick question. So sorry. So is the reverse possible with regards to the location sorry, with the payload attributes, if we've already built a system of storing on IPFS, like I guess I will meet with Seth later this week so I can kind of unpack that one. But so that we don't have to reinvent our storage architecture, like is there like some type of shortcut to assign or point that payload?
Yeah. Yeah, I think we should look at your specific use case, but at the end of the day, the location formats, it's an extensions library that we've built into the SDK, and you could write your own extension. So if you've got geospatial data formatted in a way that we don't support, as long as it's a consistent pattern, you should be able to either write a conversion script or just attach it as is and wrap it in a signature, and then it will work within your application if the code's all kind of written based on that data model, if that makes sense.
Thanks, guys. Good work.
Cool.
Awesome. I think Andreas has his hand up.
Yeah, hello. You perhaps don't know me, so maybe I introduce myself quickly. My name is Andreas, and I work for Secure Dimensions. It's a commercial company located in Munich, Germany. So I'm in Central Europe. Taylor and I, we share the OGC blockchain working group. And now that your work is approaching geospatial and location data, I would recommend that you share some of your thoughts and some of your work, and in particular, how to use geospatial data interoperable would be a great thing. So on one of your slides, you have your columns. So there's a snapshot of your database columns, and what popped into my eyes was you using SRS called EPSG colon 4326. You should never use that. That's broken. So this is one of the things, right? Because EPSG 4326 is by the Petroleum Survey Group, and they say it's latitude, longitude. But you guys are using longitude, latitude like GeoJSON, but they're using CRS-84. So here you are in troubled waters with geospatial. So my background isn't geospatial. I've been an OGC member for 24 years or something. And I learned all this the hard way, So axis order and all these SRSs and CRS and when is it this. And so I really recommend that you share some of your work with the OGC blockchain working group, and Taylor and I, we are very happy to organize these talks in during either the OGC meetings that happen every 3 months or in between. So yes,
and one of the things we can talk about, Andreas, is so I actually advertised this to that group, but I think that there are probably other groups that may be adjacent that we can reach out to as well that will have some interest.
But the actual question that I have is, of course, you can attest your location and you can digitally sign it and you can put it on the blockchain or do whatever magnificent system around it, but it doesn't make my self-attestation of a location not any more true. So what I don't see here, what's missing is the gimmick in the beginning. Well, everything else is very cool. It's really cool work. And you put all these things together. So that's great. But if I attest, I'm in Munich now, and I make that attestment, you believe it? Do you believe it just because it's an attestment? It's an attestation on the blockchain or so. So see where I'm going, right? And this discussion is perhaps something that you should share with the OGC folks, because I know that there are people thinking about this same thing, right? So how can we build it all the way,
Yeah, absolutely. And we've had discussions about this where we're thinking about it as kind of like a tiered hierarchy of certainty, right? And so the level 0 is a self-attestation, which of course brings no additional evidence, right? You trust that person. If you trust that person, then you trust it. But the idea is to bring in additional layers of evidence on top of that and have a system that allows you to package it up and use it and consume it. So this is just kind of the first little step, but the idea is not just to have a bunch of self-attestations. Of course, those could be admissible pieces of data in some applications, right? And others, you would say, I would like to have additional evidence. So that's kind of where we're thinking, where we're going with it. But yeah, we'd love to have lots of different feedback and bring this to different groups. I see Nathan's got his hand up as well.
Yeah, it's a great point, and I just wanted to connect it with some of the work we do with content provenance and authentication. There's this dream of glass to glass, from the glass sensor to the glass computer screen, that you can maintain that chain of trust. And the first round of that work was a lot of decentralized trust. We were using on-device keys and didn't care about certificate authorities. And, if you trusted kind of the key or the identity, then that would percolate and you could have your own kind of private trust list. The step we took initially was, in our what's nice about mobile app software is it's commonly signed. It's a verifiable bundle from a known publisher's identity and key. So you have trustworthy software from a reputable source that's been audited. And now if our proof mode app is generating something, well, then that data hasn't been, manually constructed and signed manually, using our source code by someone else. We achieve that through device integrity checks, which are part of mobile platforms. And then there's now in this sort of 2.0 era of that work, there's a conformance process where, we go through this process and we receive a signing key as the app itself to an additional kind of a more centralized model of trust, so that, you maybe don't need to know anything about the creator or the app, but we went through conformance and that there's trustworthiness. So I think there's a lot to learn here, and I think that we still love the decentralized approach at our core, and we'll never lose that. But we also realize that, like, if we want our video capture an app to show up on YouTube and saying this came from a real camera, we sort of have to play the game of like more of a centralized conformance. So.
Yeah, I mean, you're absolutely right when it comes to assets that someone created, that somehow got created. There are mechanisms in place, there are systems, there is software, there's design, so that you can trust it. That's all that's clear to me. But when it comes to location, my question always is, where did the location come from in the first place? And when you say GPS only, I say, come on, GPS. When the German transport government invented the toll for the highway, there was a guy who put up a GPS scammer on the Olympic Tower here in Munich. So a $20 thing, he put a 9-volt battery on it and it ran it. So all the trucks on the German highway around Munich were somewhere on the green, but no longer on the highway, so they didn't pay toll. So it took them a couple of hours to shut down that GPS scammer, but come on, right? So this is what I also have been thinking about. If you do things with location, it always becomes tricky. How can you ensure that the location is correct in the first place? And if you guys would come up with a solution where you say, oh, okay, I have 2 or 3 people in your QR code. You have a composite QR code for 3 people, and they all share the same QR code. Then you have multiple people attesting that each other was there. So it becomes more difficult to spoof the source of the location in the first place, right? So that would be something really cool to see how you can put that in your or around your location protocol. So
yep, it's a great point. That's the idea of these kind of recipes, that I don't think we have, all the answers, but we've kind of thrown ideas around, like how do you combine GeoIP with a QR code, and so trying to have some of these kind of recipes available that people then can continue combining them. But I think we could have another discussion or kind of workshop on what these strategies are, which ones are the most feasible, and what you get out of combining them. Because I don't think there's been enough thought about what shakes out of combining them.
I think some 10 years ago or so in the OGC, there was already a working group that was expanding on the GPS channel. So they were using some private GPS channels to attest that the location is really, so that a reported location is really where it is. So they were using some extra private channels from the GPS. I don't know how exactly they did it, but of course that is all classified work, and I, as a European, cannot look behind the fence, right? So the DoD does not allow that. So your DoD, I mean, right? So I guess if you now come with a solution of a decentralized system where you can feed those trusted locations in so that you do not have a single point of spoof, a single point of that you need to trust, you have a great system, a great framework to actually get things rolling. But it's still, there still is this, how can you prove that your location is really your location? And that remains the challenge to me. Sorry. Sorry for repeating myself. So.
No, appreciate it. It's great feedback. Any other kind of questions? I know we're coming up on the hour, so just to see if there's anything remaining.
I wanted to ask a question. Can I ask a question?
Sure.
Yeah, so I'm Justice. I'm more into the ZK space. So I've actually seen something around using ZK with risk zero on like proof of location. But then I'm just trying to understand something. So like listening to Nathan and listening to I think is it Andrew? No, Andreas, right? I'm seeing that what they're talking about is that they are trying to say that can we trust the source of that data coordinates, right? And I'm asking myself, okay, so there are ways that we trust sources of devices like for other like areas of like development. Maybe you're using like an RSA of like a mobile phone, like the signature of an RSA of a mobile phone. I know that okay, this particular mobile phone IP is the one that signed this to them. We know that it can authenticate to this network or like what have you. So I was thinking like maybe that problem is already solved because we can use something like an RSA key to like sign that location data and know that okay, that is from this device, and then we can use that to start the whole process. I don't know if maybe they can like talk about that as like a potential way of solving
Yes. I think there's like the turtles all the way down problem where we're trying to just get lower and lower to like the source of truth. And yeah, we can, like on an Android phone, not only do we get, say, location data, but it tells us where that came from, how accurate it is. There's timestamps. There's a lot we can pull in.
Yeah.
But if someone is sitting on the building next to me and beaming out fake GPS, or someone is moved the cellular tower that was supposed to be in another city and has moved it next to me, or has a hotspot that Google's Wi-Fi location service thinks is in a different country, it's going to confuse me and confuse what my phone sees as truth. So I think a single point of data is not always as good as we want it to be, and there's plenty of times where GPS is jammed or modified or manipulated. So I think yes, as soon as we get it in this case through this proof, it's signed, but we got to go deeper. And I know they have some good ideas about adding multiple sources of location proof.
Yeah,
Makes sense. Thank you.
Just perhaps just quickly, so that I'm not the really bad guy here. In a previous EU project, we were facing exactly the same problem. So how can we prove that a citizen science recorded something is really from the location where it was done? So for example, we had air quality monitoring. And so what we did was we implemented an application where people were not contracted, but were tasked to revisit the same location multiple times. So you had different people at different times at the same location. Sorry, it wasn't air quality, it was biodiversity. So if you have a problem with a tree or something, and someone says this tree here is broken, then you get that observation, and then you have a framework where you task volunteers to revisit that, and you select people to actually go there, and you give them some, how you call it, some goodies or something, so they get some coins, some virtual coins, and this and this. So there are ways in citizen science where you can, by redundancy, improve the possibility, the likelihood that a reported location is correct. So we did that in citizen science. So there are ways of doing it. I'm not saying it's completely impossible, but this is requires people or some. I mean, I don't know.
Cool. Well, I think we should have a much deeper dive on this exact topic soon. We've got some research and development on this exact conversation. So that is certainly at least an hour more of discussion. I'm actually think probably many, many more than that. So I feel like that's probably useful for now. We're a few minutes over the hour. Taylor, how are you feeling? Should we wrap it up?
Yeah, I think we can wrap it up. I think it's a great topic to do a future workshop or something, get people in the room together and have some kind of pre-reading and get everyone kind of on the same page and bring their ideas and produce some kind of write-up out of it. So I'll definitely keep that in the back of my mind. But Andreas, like you said, trying to interface with some of the other OGC groups as well as the blockchain group, I think could be really beneficial. And we'll keep kind of jamming on it and look forward to future conversations.
Sounds
Great.
like a plan.
All right.
Thanks.
Thanks everyone so much for coming out.
All right.
Take
Have
care.
a good one. Bye.
Bye.